In this video, we'll go through how to set up a ferment and begin entering data. Then we'll look at how to enter data for multiple ferments at once. To start entering a new ferment, first select the fermenter you wish to use from the dashboard. We'll discuss more about the dashboard in a later video once we have some ferments in progress. Selecting a fermenter opens the ferment page where we start to define the ferment. First, we'll start by filling in some information about the ferment: wine name, blend code, and batch code. If you've customized these fields in the simulator setup, they may look different for you. Once the ferment has a name, it will start to save each parameter as it's entered. There is no need to hit a save button. Select a varietal and region from the list. These lists are quite long, but you can start typing to filter and find what you want quickly. If the option you need isn't in the list, go to the contact page and send us an email and we'll add it for you. You can always change them later once the ferment is already set up. Then select a start date and time. This is the date of inoculation. The next section is for pre-ferment juice analysis. Most of this section is for record keeping purposes, but the YAN entered here does feed into the model. If measured, it should be entered here. If it's not measured, you can leave this field blank and the default guess will be used. The default is defined in the simulator setup and starts with a default of 200 milligrams per litre. The ferment setup section defines the model parameters for the simulator to use for this ferment. Some of these can be pre-filled by a ferment profile. These are explained more in the Getting Started video if you haven't seen that already. For now though, let's set it up manually. First, we'll enter a desired duration. This parameter defines what the simulator sees as being fast or slow. So the simulator makes no judgment on its own about how long a ferment should take. It simply compares its prediction to the desired duration that you've put in. Note that this is the time to reach zero BOME and may not be when the ferment is completely sugar dry. The ferment type differentiates between red and white ferments and is used to determine the sampling frequency for the data table, so either once or twice daily. This can be defined for each ferment type in the simulator setup. If you have used a ferment profile, you find that this switch is locked as it has been set by the profile. As this switch modifies the data table, you will also find that it cannot be changed once BOME values have been entered into the table. The climate switch tunes the model slightly differently for cool and warm climate fruit. This has been done using correlations from a large number of commercial ferments. Match this as closely as possible to the vineyard from which the fruit came, but if you find that the simulator struggles to fit the data you provide, try flipping the switch to see if that other tuning works better for this particular ferment. The ferment style switch differentiates between direct inoculation and wild ferments. When set to inoculation, a yeast type can be selected from the list next to the switch. The list is quite long, but again, you can type to filter the list and find what you're looking for. When set to wild, this list is not available. The wild or inoculation switch also tunes the model slightly differently to accommodate for these different styles. However, the yeast type does not affect the model. The ferment volume is entered either in kiloliters or tons, depending on whether it's a red or white ferment. The total water added field accounts for all water added with additions or for any other reason to account for dilution. Water added to the ferment dilutes the available nutrients as well as the sugar and potential ethanol. The dilution calculation affects the YAN and the initial BOME entered in the juice analysis. The calculated YAN and BOME values are displayed below the field to remind you that dilution will affect the ferment. For this reason, you should only enter water added after the juice analysis. The initial cell mass is the inoculation rate, which only needs to be entered if known. If this field is left blank, the ferment simulator will calculate what it thinks the initial yeast should have been based on the measurements that it's seen. So if inoculating from active dry yeast, then enter the addition rate of 250 milligrams per litre. If inoculating from a propagated culture, and you can calculate the dry yeast equivalent, which is shown in the tooltip, you can enter that, or you can just leave it blank and the simulator will back calculate. If it's a wild ferment, leave it blank, just don't enter 0. Any additional information about the juice or ferment can be entered in the comments section, which will be included with all of the downloadable reports. The data table holds all of the measurements taken from the tank as well as any actions performed on the ferment. BOME and temperature data can be entered directly by clicking on the cells or tabbing through the table. The units for the table are defined in the simulator setup. Clicking on the action cell in any of the rows brings up an actions and analyses toolbox box where actions performed on the ferment or lab analyses performed at that time point can be entered for data tracking purposes. Any actions performed are noted with an icon in the table if they have data entered against them. Accurate records of the actions performed on the ferment will aid the accuracy of the simulation. The pump over action signifies a mixing event, generally performed on red ferments. Any kind of cap management can be counted here, so pump overs, plunging, rotation, any of those kind of actions. The aeration action signifies another mixing event. In future versions of the model, oxygenation may be specifically taken into account, but at present we don't have the kinetic models for that. The agitation switch determines the strength of agitation used, so 1 being light agitation and 3 being vigorous mixing. The agitator setting will prevail until changed, so if it's turned on at some point, be sure to signal when it gets turned off. The addition of DAP can be recorded. Note that the units here are milligrams per litre of DAP, not units of nitrogen. The nitrogen is calculated from the DAP grade defined in the simulator setup. If you would like to work in units of N instead, you can set the DAP grade to 100% in the settings. The addition of further juice to the ferment can be recorded, so this adds sugar to the ferment, assuming the same Beaumet from the juice analysis. And this also calculates the dilution from the added volume. Any water added with additions can also be entered, so this will calculate dilution if you're adding DAP or acid or copper or anything else. So be sure to record the water that you use with your additions. You can also record any acid additions, so this is included for record keeping purposes but isn't directly fed into the model. And there's also a cell for overseeding if you're adding additional yeast after initial inoculation. So if you're using active dry, you can just put the milligrams per litre of yeast added. If you're propagating, you can use the formula in the tooltip to calculate the equivalent active dry mass. And there are also fields for any lab analyses that you might do through the ferment. So these can be recorded at each time point and will be included in the downloadable reports. But none of these lab analyses affect the outputs of the model. Any other analyses, additions or actions performed on the ferment can be recorded in the comments section. And if there are any analyses that are specifically relevant, you may wish to include them in the comments as well as the lab analyses section so that they're instantly visible in the data table, so residual sugar, for example. So there are two ways to enter data for a ferment. One is to use the data table on the ferment page, as we've just looked at, for each individual ferment, which is okay if you're just focusing on one ferment at a time, but if you have many ferments to enter, this can be a bit cumbersome. The other method is to go back to the dashboard and click the data entry button. This will generate a table of all active ferments that don't currently have a Beaumet entry for the current time point. You can filter this list by tank group or change the time step from the current time with the date picker. When using the bulk data entry method, the ferments will be queued for simulation and run when the processor is free. This means that directly after entering data, you may see a lot of out of sync warnings on the dashboard. If you wait for the simulator to work through the queue, these warnings will clear on their own. Alternatively, if you wish to see the simulation for a particular ferment immediately, you can enter that ferment page and just click Run Simulation.